objects and classes, back at it. In this video, we're going to visit a lot of smaller things that we've kind of glossed over when just going through the code. We're going to look at these smaller things. We're also going to be coding up that initial example again, but really quickly so we can see how NetBeans can help us take advantage of some of the code completion and the assist that it gives us to make the getters, make the constructors. It's going to be fun. Let's jump right in it. We've mentioned this previously, the reference data fields. Data fields can be of a reference type, such as this string name here. That is not a primitive, right? String is an object. So that is a reference data type. And as we've seen, the data members in our classes, in our blueprints, they get initial values when we create objects, even primitives. But in particular here, the focus is on this reference data type, a string, for example. It will be given a default value of null to signify that it's not pointing anywhere, that no string has actually been created. As we've seen as well, the primitives get a default value. Age will get a default value of 0. A Boolean gets a default value of false. And a char value gets a default value of the Unicode value of all zeros. So all data members will be initialized, even primitives. And here are those initial data values that can be assigned. If a data member of a reference type does not refer to or point to any object whatsoever, that data member will hold a special value null, which really just signifies that it points to nothing. So this is in contrast to when we simply create variables. For example, in a main program, in a method, if I create this variable x has no default value, right? If I create this string y has no default value. So when I try to print those two respective variables, Java's going to understandably cop an attitude, shout at me in red, and ask me what the hell am I doing trying to print x and y when I've never actually given them a value. So we would get a compile error because no initial values are given. However, when creating objects from blueprints, it's important to remember that those initial values are given. So here's also a distinction between a primitive data type and a referential data type. So here, a primitive data type, if I say int I equals 1, what's really under the hood in memory? I is, we have 4 bytes, right? And it's an integer, which has 4 bytes. And I has this space reserved in memory of 4 bytes, which we save the value 1 into. Whereas if I have a circle that I've referenced with this variable c, what's actually saved inside c? Well, currently null would be saved inside there if I've not actually created a new circle object. But let's assume that we do actually create a new circle object using the constructor, using the new keyword. So what's going to be saved inside the variable c? It's going to be an address, or in Java terminology, a reference. A reference to what? To the location of that circle object in memory on the heap. Also, assignments. It's important to pay attention to assignments and understand the nuances of assignment operators with primitives versus with objects. So here, if we have these two primitive integers, I and j, before this assignment, we're going to make this assignment of I equals j. Well, before assignment, imagine that I has the value 1 and that j has the value 2. Well, after the assignment, clearly, we're taking what is in j, which is the 2, and we're saving it into I, so now both I and j have the value 2. Like, wow, right? Your world has been rocked. No, we already knew that. Well, pay attention to what happens when we do that same type of assignment now with a referential data type. So here, if we have these two objects, C1 and C2, before the assignment, C1 points to this circle object with a radius of 5, and C2 points over to this circle object with a radius of 9. So what if we make this assignment C1 equals C2? We're really taking what is inside C2 and we're saving it into C1. We're taking what's right inside here, C2, and we're saving it inside C1, which means what? That means that C1 is now going to point to refer to, the exact same object that C2 points to. And in fact, in addition to that, this object that was initially referenced by C1, by the variable C1, it's no longer referenced by anyone, and it is therefore considered garbage. That is the official term, garbage. And garbage is automatically collected by the Java garbage collector via the Java virtual machine. So as soon as an object is no longer referenced, meaning like normally a variable like C1 would point to an object, or if you have a student object and you say student S equals new student, so S is pointing to that new student object, right? Well, as soon as S no longer points to that student object, for whatever reason, maybe you did something in your code and S no longer points to that student. So as soon as an object is no longer referenced, what happens? The Java garbage collector happens. It has no mercy. It will delete that object with reckless abandon, with no hesitation. It waits on no one. So the Java garbage collector will come delete any object that is no longer referenced. And here's a tip. If you know that an object will not be needed, you can explicitly assign null to the variable for that object, and then the Java garbage collector will come and will automatically delete that object that was previously referenced. This here, just the 2 quick slides, the publisher mentioned like in the middle of nowhere, really. They said, hey, we have a date class, and they talked about it briefly. So I'll do the same for 60 seconds or less. Java gives you a date class. It's a built-in blueprint that is a system-independent encapsulation of date and time. That's all you got to know. There's a date class. It's available to us. We could make a new date object, and then we could print date.toString, and we would get something like this. Not the most helpful, to be very honest. Something the publisher chose to mention. I choose to mention. No harm in knowing some of these extra blueprints, these extra classes that Java provides for us. All right, we have finally made it to visibility modifiers. We've talked about this in many videos. We've done a lot of hand waving, right? Where I've said, hey, what is public? What is static? What are these things? Well, here we are. We're going to officially now talk about public and static. By default, the class, the variable, or a method can be accessed by any class in the same package. And remember, package, even though we usually don't use packages because we're not making large, pieces of software with maybe hundreds of Java files working together, we're usually making 1 or 2 Java files, right? So there's no need to make or use packages usually for our purposes. But in industry, when you're having dozens, hundreds of files working together, you want those files organized in a nice file structure in folders. Well, those folders are also known as packages, as we've discussed way earlier in previous videos. So when you're making these packages, it's important to know that by default, a class, a variable, or a method can be accessed by any other class in the same package. And what do I mean by default here? Meaning if you don't mention the word public, or if you don't type the word private, that variable or class or method that does not have the word public or private on it, it can be accessed by any class in the same package. But Java also gives us visibility modifiers, public and private, as well as protected, which we'll come to later. But public and private that allow you, the developer, to specify the level of visibility that you want for those variables and methods in your class. So if you specify the word public before a variable, for example, or before a method, this means that you're allowing that variable or that method to be visible to any class in any package anywhere on Earth. Not anywhere on Earth. Within your, of course, your computer, within your project environment. That's what public does. Visible to any class inside any package. But the key word there is any class and any package. Privacy, what private does, that particular visibility modifier, it says you can only access that variable or that method only within the class that it is found inside. So if you make a variable private, you can only access that variable from inside the same class. You can only access it directly. If you make a method private, you can only access that method from inside the same class. So here's a quick example. We have here a client and a service. So here's this service. Let's look at this first. Class service. It says public int member1, private int member2. So we have two data variables, two data members, member1 and member2. Member1 is public, member2 is private. And now we have a method, a public method that is void, that says do1, and we have another method that is private that says do2. So here's this, it's called a service. It's a class, a blueprint, right? And now we want the client who wants to be able to make a new object of this particular service. So here we say service obj equals new service. We've made a new object. And we want to try to identify which of these data members are accessible and which of these methods are accessible. Because here we're making this new service object. We're not making it inside the service class. We're making it in some other class, right? This could be like some demo class, and this is inside a main method. We've made a new service object that we've saved inside this variable obj. So if we type obj.member1 equals 10, does that work? The answer is absolutely that works, because member1 is public. We can access this public variable, member1, from any class, any package. What about member2? That will not work. I cannot say obj.member2 equals 20 because member2 is private. It's only available and accessible from inside this service class directly. What about obj.do1? That is a public method. It's available, accessible within any package, within any class. And then finally, obj.do2, not accessible to us because it is private as well. Important to understand that. And here's a very detailed example that I want to comment that if I just, when I go through it without making the following comment, a lot of times learners are like, oh, this is easy, it's not that important. But then if they go have a test on this material, they're like, wait, what happened? I don't understand it. This slide, as well as the next slide right here and here, very important concepts to understand visibility. So I'm going to go through this in detail. So here we have, notice, we have three different classes. We have class C1, we have class C2, and we have class C3. So class C1 and C2, they are both inside the same package, P1. Remember, a package is a folder. So think of those two classes, which are two Java files, right? This is a Java file called c1.java. This is a file called c2.java. They're both inside the same package, the same folder, which is called P1. Here we have another Java file called c3.java. It's another class, and it's in an independent folder, a package called P2. So let's try to first remind ourselves of what we said on the previous slide, that the private modifier, what does it do? It restricts access to data members, to variables, and to methods to within the same class that they are defined. The public modifier, unrestricted, you got free access anywhere, everywhere. If you use neither of those modifiers, you don't put the word public or private, that means you have default visibility, which restricts access to a given package. So with all that in mind, let's start over here on the left. We have this public class C1, and it has three variables and three methods. Let's very quickly look at those variables. X is public, Y is neither public nor private, and then Z is private. So Y has default visibility, X is public, Z is private. We have three methods. M1 is public. M2 has default visibility because it neither mentions public or private. And then M3 is private. So with that in mind, now let's look at class C2. Inside class C2, we have a method that's literally called a method. And inside that method, we make a new C1 object, right? Because C1, it's a blueprint. We've made a new object of type C1, and we save its reference into this variable O. So what we're doing here in the slide is it's just letting you know, it's a nice example of letting you know, well, hey, from inside this class C2, now that we've made this new object of type C1 from this C1 blueprint, what all can we access within that object C1? Well, here it says we can access the X data member. Why? Because X is public. You got free unrestricted access. We can also access the Y data member here. Why are we allowed to do that? Because Y is default visibility, right? It doesn't have public or private. It's default, therefore. And the default visibility restricts access to within a package. So here, we can access Y, even though it's not public. How are we able to access variable Y? Because we are in the same package P1, the same folder, the same package. We can therefore access variable Y. However, we cannot access variable Z because Z is private. And a private variable can only be directly accessed from inside the same class. So here we're inside class C2, even though we've made this object of type C1, and even though Z is a variable of that object, it's a data member of that object C1, we cannot directly access Z over here inside class C2 because Z is private. And it's therefore only accessible inside the same package that it was defined in. Now, what about the three methods? We can go quicker now. Method M1, we can access it, it's public. Method M2, we can access it because it has default visibility and we are in the same package, right? Package P1. But we cannot access method M3 because M3 is private. And a private method can only be accessed from inside the class it was defined in. So now let's come over to class C3. We're now in this third Java file, c3.java, which is in a different package. So here we're going to see that we can still access variable X, because X is public. We can still access method M1 because method M1 is public. And I should back up and say, in the same way that we did here with class C2, inside class 3, we have a method called a method, and we have this object C1 that we are creating, which comes from this class C1. And the same thing is we want to see, well, which data members of C1 do we have access to within this class C3, and with which methods do we have access to? So we have access to X because it's public, and we have access to method M1 because it's public. We do not have access to Z and to M3 for the same reason we've already mentioned over here, because both Z and M3 are private. They are both only accessible from inside class C1. But what's different is now we no longer have access to Y or method M2. And why is that? Because remember that Y has default visibility, method M2 has default visibility. And what does that mean? That means that that method M2 and that variable Y, they have default visibility, which means that they are only visible to anything within the same package. But because we're in a different package, we no longer have access to them. Very important slide. You've heard me say that now multiple times. Very important to understand those visibility modifiers and their nuances. Also, we can put these visibility modifiers on the classes themselves. Let me back up and show you. Here we were looking at public and private, and we were putting the word public and private on variables, or public and private on methods. Well, we also noticed that each one of these classes had the word public before it. But what if we don't have the word public before? What if we just say class C1 and we don't put the word public before C1? So the default modifier on a class, so if you don't put the word public before a class, what happens is it restricts access to within a package. So here, if we have package P1 and we have class C1, here we have another package, and inside this package we have class C2. Class C2 is able to access class C1. Why is it able to? Because C1 has default visibility, and both of those classes, C1 and C2, both those Java files, they're inside the same folder. They are inside the same package. So therefore, class C2 can generally access class C1. However, let's now look at over here at class C3. We see that class C3, it cannot access C1 at all. Why can it not access C1? Because because class C3, this Java file, c3.java, it's inside a different package. Because it is inside a different folder, a different package, class C3 can no longer access class C1 because class C1 was not public. It had default visibility. Now, in contrast, we see that class C3, it can access class C2, right? Class C3, it can access class C2 even though they are in different packages. How does that allow to happen? Because class C2, it was defined as public, which is unrestricted free access. So as was mentioned on the previous slide, this is super important. Make sure we understand these nuances of a public modifier versus having a default modifier on the class itself. So here we have one final slide on this. We have two examples down here at the bottom. We have public class C. So here's a blueprint, public class C, where we're going to make objects of type C, of class C. And over here we have just this public class test, which has a main method, and we're going to make an object of that type C. Now this public class C, it has a private variable x, which is a Boolean variable, it's private, and it has a private method called convert. So when we come over here to this test class, which is a different class, a different Java file, and we make this main method, and we make this object of type C, it of course now makes sense to us that, hey, I cannot access this variable x because it's private. I also can't access this convert method because even that convert method is private. Private means we can only access those data members or even private methods from within the same class. So here I would not be able to access x or even this convert method. However, which is kind of weird to do this, but you can, notice that we have this blueprint C, right? We have this class C. It has a private data member, a private data member variable x. We also have this private convert method, but also we make this public method, which it's static. And we'll talk more about what is static. So static does not belong to the individual objects. It belongs to the blueprint, to the class. So we have this static main method. And here inside the blueprint, which is kind of funky to inside the blueprint to have a main method, but we did on this example. Inside the blueprint, inside this class, we've made a main method and we're making a new object of type C. Therefore, within this class, we're able to access c.x and c.convert because we're strictly within the same class. Again, it's kind of weird. You would not normally do that, but this was just demonstrating that you can access those private methods if you make an object of that type C within the blueprint itself, which again, you would not normally do, but we did this inside a main, so it's okay, and we'll talk more about that. So privacy. Data members should be private. The default is to give your data members private access. This is the standard for OOP. What's the purpose? The purpose is to protect your data. You don't want other classes, certainly other packages, to have free access or free reign to your data members. The internal details of a class, they are declared private and they should be hidden from the clients. This is a new term for us, a very popular OOP term called information hiding, a very famous OOP paradigm or OOP technique. Information hiding, it guarantees exclusive data access only to class members. This protects and it maintains the integrity of your objects by preventing unintended or even intended changes or intrusions. So therefore, the question, and we've already seen the answer to this in class, so I'm going to go a bit quicker here on these slides now. Data members of a class, they have to have, or they should have, private visibility. This means they can only be directly accessed from within the class itself. How then are other classes able to access or even modify that data? Via accessor and mutator methods, via those getters and the setters. So at the discretion of you, the developer, you may choose for given private data members, you may choose to make getter methods or accessor methods. You may choose to make mutator or setter methods. So here is that previous circle class that we saw. And the only difference here is now I'm taking the radius and I'm making that data member private, which means radius will no longer be accessible to any class outside of this circle class. Therefore, if we want to access that data member radius, we need to make a getter method called a getRadius, or an accessor method is what it's also known as. And what are we going to do here with this getter method? We're just going to return the radius value. It's that simple. Get radius, return radius. Public void set radius. This is a setter method, also known as a mutator method, where we're going to send over a radius value called new radius, and we're going to save that radius value into the data member radius. And notice that these getter and setter methods are public, so we can access those methods from outside this class. So here the developer, in this case it would have been you, have made these getter and setter methods strictly so people, users outside of this class are able to access the data in radius or even mutate or set the data in radius. Important to point out on this slide is that the parameter here is called new radius. And here the parameter for this setter method is called new radius. This is not the correct way of doing this, and we're now going to cover what is the correct way. So looking at that constructor again, the parameter name is called new radius because we haven't officially seen the correct way of doing this. This is not the correct OOP way of saving this parameter into the data member radius. The only reason we're doing that is because, again, we don't know the correct way. What is the correct way? Well, if we know that we want to have a data member called radius, it makes sense that the parameter should also be called radius. So let's change it. Let's actually make the parameter called radius. And now let's have this line of code say radius equals radius. What happens if we do that? Our intention of this line of code, radius equals radius, is simply this. We're telling Java, take this parameter, double radius, and save its value into the data member radius of this particular object that we are constructing. That's what we want to happen. That's what we're asking Java to do, to take the parameter and to save it into the data member. What actually happens is Java's a bit confused. Java's like, really, dude? You want me to save radius and save it into radius? That's big brain, but I'll do that for you. What Java's really doing is it's going to take the parameter radius and save it right back into radius. Similar to if you had this int variable x and you gave Java the command x equals x. Well, Java would do it for you. Java would think you're a bit crazy, like you've lost your mind, but it would do it. It would save x back into x for you, no problem. But that does nothing. Why does this happen? The key word is scope. Java examines this constructor and it only sees a single variable called radius. Thus, any use of this variable radius right here is assumed by Java to be referring to the parameter. So when you say radius equals radius, Java's like, cool, I got you. I'm going to save your parameter radius into the parameter radius. Why do you want me to do that? Java's like, I don't know, but I got you. I'll do it for you. So our previous hack of a solution was to do what? We simply used a different variable name for the parameter. We called it new radius. So now when Java sees this command radius equals new radius, Java does not see any other local variable called radius, right? Because the parameter is called new radius. So when we have radius equals new radius right here, Java sees this variable radius and it realizes, oh, because there's no other usage of the word radius or the variable radius, this must be referring to the data member radius, right? So again, what's the solution that we've already seen? The solution is to use the keyword this. Here's what we wanted to have happen with that line of code. Remember, we said Java, take the parameter, in this case radius, and save it into the data member radius of this particular object that we are constructing. So this is the solution. The solution is to use the Java keyword this. The this keyword in Java, it refers to the given object itself. The common use of the this keyword in Java is to reference a class's private data fields, which is what we just did, and to avoid ambiguity when parameters have the same name, right? So here, if this parameter has the same name, if I had not put the word this right here, and I just said radius equals radius, that's ambiguous to Java. And so Java assumes you just want to save the parameter into the parameter, which of course makes no sense, but it'll do it for you. But by typing the word this, what we're saying is, yo, Java, take the parameter radius and save it into the radius data member of this object. Which object? Well, we're in a constructor, right? Right? This is a constructor. We're constructing an object. So take the parameter radius and save it into the radius of this object that we are currently constructing. And in that same vein, for the setter method, for the set radius, when we send over this radius value, we should use the same name. And this once again says, take this parameter radius and save it into the radius data member of this particular object. Which object? The object from which we called the set radius method, right? You would have had an object and you would have said object dot set radius, and we would have given it a parameter. So set this data member, set this parameter radius into, or assign it into the radius of this particular object that is currently under consideration. That is the this keyword. Now, another common usage of the this keyword is to enable a constructor to invoke another constructor of the same class, which is kind of funky. It's really cool, and it's called constructor overloading, or an overloaded constructor. So here in this example, we have a class circle, and we have the same double radius. Here we have a basic constructor where we're assigning radius into the data member radius, as we've just described. What about if we have a second constructor, which is a default no parameter constructor? What if I wanted to just set here radius equal to 1? I could have literally just written radius equals 1, and that would have worked just fine. But the purpose of this example is I want to show you how we could have used the keyword this. Inside this no parameter constructor right here that I have the mouse moving over, instead of typing radius equals 1.0 semicolon, which I could have done, instead of doing that, what did I do? I typed the word this, and then in parentheses, I put 1.0. So what happens when you do that? When you type this inside a constructor with parentheses, that is a command to Java to call another constructor. Which one? Well, to look for one that has one parameter with a double. So Java is going to take this parameter 1.0, and it's going to go examine all of your other constructors that you have. In this case, we only have one other constructor. and it's going to look for a matching constructor that has a single parameter, a double. And sure enough, it finds this constructor. And so it takes this 1.0 and it sends it right here to radius. And then we take radius, the 1.0, and we save it into the data member. Finally, this last method is getArea. I wanted to point out that there's no harm in typing this dot radius times this dot radius times math.pi. There's no harm in doing that. But I also wanted to say that we would usually omit this keyword this right here, and we would omit the keyword this right here before radius. Because inside this method, there's no ambiguity, right? There's no other parameter. So even if you don't type the keyword this, Java only sees the word radius, it knows you're referring to the data member radius. There's no harm to type this dot radius, but since there's no other radius in question, Java already understands that you are referring to the data member. All right, it is code time. We're going to go code up that original OOP demo example, the one with getters and setters. We're going to do it again from scratch, and you're going to want to do it from scratch with me. Why? Because we're going to do it super quickly in NetBeans. We're going to make a student class. We're going to make an address class. But the key thing here is we're going to show you how NetBeans can make your life so easy. NetBeans is going to make the constructors for us. NetBeans is going to make the getters and setters for us. You are no longer going to be typing that. You're going to love every single second of it. Let's go right over to NetBeans. And we're also going to make this print details method, a comprehensive print details method that will print the details of a given student, as well as even the address in that particular, for that particular student. So here we come over to NetBeans. Let us make a new project, file, new project, next. Let's call this OOP demo final, right? Let's get rid of the package. I will call the class OOP demo final, not main, but I'm going to get rid of the package. Okay, hit finish. Let us do this. Let me zoom in, delete this, zoom in a bit more for you. I don't know if I'm going to want to use anything in the util class, but I'm going to go ahead and import it, java.util.star. Pause the video as you need. I'm going to go a bit fast here, just at the beginning. I want to come over to my default package here. I'm going to right click on it, new Java class, and let's call this address. Finish. Let me zoom in here. So a given address, so a student would have an address, right? This will have which fields will be an address. Usually a line address 1, an address 2 for like an apartment, address line 1, line 2. So let's call this string address line 1. Let's call it line 1. String, do you call it address line 1 or just address 1? Let's call it address line 1. It feels better. String address line 2. String city, string state, and string zip. Type that up, and now guess what? Check this out. I'm going to go to right click. I'm going to come to insert code. And here I'm going to choose getter and setter. I'm going to hit select all, and I'm going to, if I just hit select all and hit generate, it's going to make the getters and setters. But I didn't type the word private up here. So I'm going to hit Control Z. Let's do this again. Right click, insert code, getter and setter, select all, and then click encapsulate fields, which is for information hiding. And now we have private. That's exciting. Come on. You know that that's awesome. So now we have, 40 something lines of code. We have all the getters, all the setters done for you. Let's go back now and make our student class. Right click, new, Java class, student. And some of you are like, why did you not tell us this before? And the answer is we need muscle memory for getters and setters. We need to have coded those a few times. We need to have coded some constructors a few times. Speaking of which, let's come back to address. I did not make the constructors yet. So let's right click right here. So I hit enter twice after zip. Let's right click right here, insert code, constructor. Let's make a default constructor. So I'm going to hit generate without selecting anything. I'm not checking any of those. Let's hit generate. Let's also right-click, insert a constructor, and let's select all of those. Select all, generate, done. Beautiful. Notice how it does it all for you with the correct OOP concept of using the this dot and using the same names. Done. So if you want to put some comments in here, you can. I'm going to go ahead and put here constructors. It's obvious, but I like to do that. Constructors. And here is data members. Cool. Let's come back now to our student. So what is inside the student? We're going to have string first. Let's call it int ID. Let's start with that first. Int ID, string first name, string last name. What else? We want it to have an email. So how about string email, double GPA, and then finally, let's get rid of, we don't need all this right now. Let's just get rid of, let's do ID first name, last name, and then address A. So now let's make a constructor, insert code. Let's make an empty constructor. And let's make another constructor, but it's not going to make it the way we want, and you'll see why. But I'm going to go ahead and make another constructor, and I'm going to select, I wasn't going to say I'll select everything. I'm going to select just these three, ID, first name, last name, generate. And then let's now make, and I notice I did not select the address. Let's insert code, and let us now make all of our getters and setters. Select all. And the address is going to look a little bit weird, right? Because here, address, get A, it's just returning A. Well, what is A? A is a reference. It's a reference to an address object. Speaking of which, and we briefly covered this on a previous video, but it's very brief. When we make a new student, even inside this default constructor, remember, ID is going to be given a default value of 0. First name is going to be given a default value of an empty string. What happens with A? We showed you that A will get a default value of null, which means that A currently points to nothing. Well, that makes no sense. You want A to point to an address object. When is the appropriate time to create that address object? It's when you're creating the student object. So here you really want to say A equals new address. So here inside the constructor for student, even in the default constructor, we want to make a new address. And in fact, we want to do the same thing here. Let me put a comment. Come on. Inside this constructor, let's make a new address object and save it into A. So now we've made a new address object, we've saved it into the data member A. So A is storing a reference to that object. And I'll put a comment for this in a moment. Let's also say A equals new address here. And so now we've made a new address within this other constructor. Now here's what's going to be a bit different. In this other constructor though, we will want to go ahead and send over the string address line 1, string address line 2, string city, string state, string zip. We will want to send all of those values over to this constructor. However, we're not going to assign them directly because there's nothing to save them into, right? Instead, what we're going to do, and we've seen this, we're going to forward on each one of these 5 parameters right here. We're going to forward them on to the address constructor that you see right here, so they can be assigned within that address constructor. So if we call the student constructor that has all of these parameters, well, the first 3 parameters we're going to save into their respective data members. The other 5 parameters we're merely going to forward on. And we've seen this previously, so I can give less of an explanation on that. Line 2, city, state, and zip. Cool. But now we have a student class. Done. So easy, so quick. NetBeans did that for us. Finally, let's come back over here to our main. Let's make a new student object. Student S1 equals new student Feel free to put your own information here. What is the ID? I need to send over. Come over to student. We have ID, first name, last name, and then all of the address fields. So the ID, apparently my ID is going to be 111-7777 is my ID. Name, Jonathan. Last name, Cazalas. And what comes next? Address, line 1. What is my address? My address is 111 somewhere Boulevard. I am in Lakeland. Oh, wait, I need an address, line 2. Suite, or what is the office? Office number 108. And what is the city? The city is Lakeland. The state is Florida. And then the zip is 33810. So I have an ID, a first name, a last name, and then I have all of the fields of an address. So how can I print that now? This is what I want to end with. We made previously this print details method. Let's make that again inside this student class. So let me come in here and also put those comments, data members. Let's put this other comment here, constructors. Let's put this other comment here, getters and setters. And let's come all the way down after the getters and the setters. And let's put here a comment called other methods in this class. And the other method here is simply going to be called public void print details. And in this method, we just want to print from our main. I want to be able to say print, I want to be able to say S1 dot print details. I want to call that method, and I want that method to print everything about the student. So let's just type this in really quickly. So here we want to print what? Let's do formatted printing. I have that built in to give a printf. So I want to say ID colon. Let's put a lot of spaces, and let's say %D, new line. And this is going to just be, I can print the ID directly because I'm inside the same class, right? ID is private, but I'm inside. Ooh, I forgot to encapsulate the fields when I right-clicked that. You probably were shouting as you watched the video. So let's encapsulate all of these. Private, 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 space, space, space. All of those should have been private. So even though it's private, it's inside the same class, so I can access it. Let's do the same thing with first name. So this should be first name. Let's get rid of these spaces. This is going to be %S, first name. Let's do the same thing with last name. I'm trying to space this over a bit nicely so it looks appropriate. Last name. So let's space this ID over so it fits as well. Cool, there we go. And now how do we print the address? This is what I wanted to focus on. Well, in order to print the address, we need access to that address. Now realize we have access to A because A is a private data member of this class, right? We have this variable A, and A points to, so A points to the address object we created. So I can now use those methods from A. So here I'm going to, let me just copy this line of code. And I'm going to type address line 1. I'll call it just address, no, line 1. Address line 1, which means I want to space over all of this so it is equally spaced. So it lines up. Cool. Address line 1. So what do I want to print here? I want to say a dot get address line 1. So check that out. And I'm going to copy this. Address line 2. A dot get address line 2. Here this needs to be city. Let me space this all over. A dot get city. And I'm going to copy this line, less editing needed. twice. And this is going to be state. Oh, come on. Double click. State. And then finally zip. And this is going to be get state. And this is get zip. So I typed that quickly. You can pause the video. I may have made a mistake. Let's find out. Let me come run it. And I'm waiting for it to shout at me and say I made a mistake. But ID, Jonathan, Kazalas, address, line 1, line 2, city, state, zip. Perfect. So I was hoping to finish a few minutes earlier, but this is what I wanted to accomplish. What we did here was simply using the features of NetBeans to make our life super, super easy. We made the new student class, the new address class, had NetBeans knock out those getters and setters for us, had NetBeans knock out the constructors for us, and then we simply made a new student and we called that print details method. That print details method, of course, the main thing that was cool here was that we're accessing the data members directly for ID, first name, and last name, but then for the address object, we're accessing them via their getters and their setters within the address blueprint. And guess what? We're done. It's been fun. As always, reach out, leave a comment if you have any questions. Take care, everyone.